Have you ever found yourself scratching your head over complex programming concepts like isomorphism and homomorphisms? You're not alone. Today, we're diving into these fascinating topics to help you understand them better. I totally get it. These concepts can feel overwhelming, especially when you're trying to apply them in programming. Many learners struggle with this, and it's completely normal to seek clarity. Let's take a look at the specific question that sparked this discussion. One user asked, "What are isomorphism and homomorphisms in the context of programming?" They shared some examples from a book, and we're going to break those down together. To understand these concepts, we first need to grasp what a homomorphism is. In simple terms, a homomorphism is a structure-preserving map between two algebraic structures. For instance, the length function on strings is a great example. And stick around. By the end of this video, you'll not only understand these concepts, but also see how they apply in real programming scenarios. Let's begin by understanding why the example provided is a homomorphism. The user can think of a homomorphism as a structure-preserving map between two algebraic structures. In this case, the length function takes a string and returns an integer while preserving the operation of concatenation. Next, let's discuss why the length function preserves the monoid structure. A monoid consists of a set equipped with an associative binary operation and an identity element. The length function maintains these properties when applied to strings. Now, the user may wonder if the map function on lists is also a homomorphism. The answer is yes, because it also preserves the structure of the list when applying a function to each element. Moving on to isomorphisms, we need to understand that a monoid isomorphism involves two homomorphisms that act as inverses of each other. This means that applying one after the other returns the original element. Finally, let's clarify why the Boolean monoids and the string and list char monoids are isomorphic. The user can see that both pairs have a structure that allows for a one-to-one correspondence between their elements while preserving operations. Moving on to isomorphisms, these are a bit more complex. An isomorphism between two monoids means there are two homomorphisms that can invert each other, essentially showing that the two structures are equivalent. Fun fact, did you know that isomorphisms can be found in nature too? Just like how different species can evolve similar traits, mathematical structures can share the same properties. Now let's look at the answers provided by other users. This user explains that the length function is a monoid homomorphism between the monoid of strings with concatenation and the monoid of natural numbers with addition. They highlight that length preserves the monoid structure by ensuring that the length of an empty string is 0 and that the length of concatenated strings equals the sum of their lengths. They further define a monoid homomorphism as a function that maps elements from one monoid to another while preserving their structure. This includes mapping the neutral element of the first monoid to the neutral element of the second, and ensuring that the operation results are consistent across both monoids. Here's a takeaway. Understanding these concepts can significantly enhance your programming skills. They help you think about data structures and algorithms in a more abstract way. And that's a wrap. You now have a clearer understanding of isomorphisms and homomorphisms. Keep exploring these concepts, and don't forget to subscribe for more insightful programming content.